Talking about angles. So let's start. Adjacent. Anybody else hear the word adjacent and think next to? Anybody says adjacent to me, I think, you live adjacent to me, you live next to me. I think next to. So what's it mean for two angles to be adjacent? All right, you got to go through a little checklist. Number one, they have to share a vertex. Number two, they have to share a side. And number three, and I'll go over this in a second, they can't have any common interior points. No common interior points. I'll show you what I mean in a second. So everyone look at letter A for me. X and Y. Are they adjacent? Well, ready? Do they share a vertex? X and Y. Angle X and Y. Do they share a vertex?
Yeah.
Yep. Perfect. Do they share a side?
Yeah.
Yes. Okay. Here's what it means to have no interior points in common. Every one of you right now, put a point inside angle X for me. Put a point anywhere inside angle X. Is that point also in Y? No. Can anybody put a point in X or Y that's going to be in both of them? Anybody? I don't think I can either. I put some random point in X here. I can't put a point that's going to be in both. So that means they have no points, interior points in common. That's what it means. So what do we know about these two then? What can we call angle X and angle Y here? They are adjacent to each other, correct. They share a vertex and a side, and they do not have any interior points in common. All right, how about B? How about that sucker? What do you think about B? No? Why not, Luke? They're next to each other.
They don't share a vertex.
Done. They don't even share a vertex. So forget about looking at the other stuff. They don't even share a vertex. So not adjacent here. And all right, before we do this final one, let me give an explanation here. Angle X is referring to the whole angle here. Everybody good? That's angle X, the whole big dog. That's why I drew that big arc mark there. Angle Y is this one right here. I'm just going to do quickly in green, just so everybody knows angle Y and X. Okay, angle X is the full one. Angle Y is what I have in green. All right, are they adjacent or not? Do they? Whoa, relax. Do they share a vertex? Yeah, they do. Do they share a common side? Yeah, that vertical one on the left they share. Do they have interior points that are in common? Yeah, unfortunately, right? They do. Here, if you don't see it, is this point's in angle Y? Everyone agree? And it's also in X. They can't be in both. They got to be separate. So these two are not adjacent to each other. Great. Questions from you guys? You probably heard of the next term, right? Complementary. Anybody? Complementary. Back in the day, two angles that add to 90. Yeah, usually, yeah, that's good. I need a little more detail in this class, though. Two angles. Well, what if I have three angles that add to 90? Anybody know what that's called? Three angles that add to 90. Complementary is specifically reserved for two angles. Okay, two angles only. So here is probably what you remember back in the elementary school days, right? You probably had an angle here, I'll throw in 50 degrees, and you probably had an angle going here, and I'll throw in 40 degrees. That's probably what you remember, right? Those are complementary. Why? They add to 90. Not in the high school anymore. Those diagrams don't fly. Here's the diagram you're going to need. You tell me why these two are complementary. That's big boy, big girl diagram. How do I know angle 1 and 2 are complementary without even saying the word 90? Lisa? Oh, I thought you had your hand raised. Sorry. Go ahead, Zach. What's the right angle symbol mean? It's 90 degrees, right? That angle's 90. Correct. So does everyone see 1 and 2 complementary because they add up to 90? All right, bonus. 1 and 2 are also what? No. Oh, Callum, my heart. Did I say bisector? Did I put congruent marks? Don't assume. All right? Don't assume. They're not congruent. But they are Now you want it? Now you want a piece, Lisa? Go ahead. Darn right, adjacent, aren't they? They're adjacent. I want you to keep using this vocab. All right? They're complementary and they're adjacent. Great. More you want. Supplementary. Not add to 90, but add to a $1.80, 180. That's two angles still. Two angles. Two angles that add up to 180. Can't be three or more. All right, so again, I'll do the old elementary school version and then the version I need you to be familiar with. Ready? Elementary school version. Hi, I'm 120. I'm 60. I'm supplementary. Ooh, great, great. You ready for my version? In this class, anyway? Ah, shoot. Wrong direction. There we go. No symbols, no nothing. How do I know those two add up to 180? Talk to me. How do I know they add up to 180? You going to try it, Scott? Well, what's a straight line measure? 180. All right. 1 and 2 add up to that straight line, which we know straight lines are 180 degrees. So yes, they're supplementary. And they are adjacent. Good, good, good. All right. Have I thrown too much at you right now? Good, because I'm going to keep piling on. Ready? Whoa, whoa, I'm not done yet talking about our supplementary up here. We just said they're supplementary, and what other type of angles are they? Adjacent. So I'm going to give this a new vocabulary term. If two angles are adjacent and supplementary, they do both. Now you can flip the page for your new vocabulary term. If two angles are adjacent and supplementary, we're going to refer to them now as a linear pair. Linear has the word what in it? Line, pair, two of them. Two angles, two adjacent angles that form a straight line. Okay, that's a linear pair. All right, so part A, do you think angles 1 and 2 are a linear pair? Uh-oh. Linear pair, angles 1 and 2? They are adjacent, but they don't do what? They don't form a straight angle, right? Absolutely not. So these are not linear pairs. Part A, not linear pairs. Thank you, Michael. Enjoy your day. You too. What about B? Linear pairs? Are they adjacent and form a straight line? Yes, so they're linear pairs. And how about C? Those look linear? No, they're not even what to begin with. Forget about a line. They're not even adjacent to each other. They don't share a vertex, so we can stop talking right there. Not a linear pair. Okay, good. All right, now comes a big moment in your geometry careers, for this year anyway. Learning your first theorem. First, you've heard of Pythagorean theorem, but what is a theorem in general? It's a true fact. All right, it's a true fact in geometry, and I want to be real with you. Probably I'm going to give you about 50 plus theorems during the course of the year, okay, that you're going to be able to use in a problem. All right, first theorem here deals with the linear pairs. All right, first theorem, just think of it as a fact. Linear pairs are, and there's a blank, going to be a blank there that I want to help. You're going to help me fill it. And it's not adjacent. That's the definition. A true fact about linear pairs, other than they're adjacent. That's kind of like the definition. Look at part B. 1 and 2 are linear pairs. Can you tell me anything else about angles 1 and 2 other than they're adjacent? Because that's like a definition. Lisa, what else do you know? What's that? Yes, thank you. They add up to 180, don't they? So instead of saying they add to 180, let's use the vocabulary term. Lisa, one more time. They're supplementary. Linear pairs are supplementary. There's your first geometrical fact of the year, that a linear pair are supplementary. All good. Questions? So there's linear pairs. I don't think you've heard of these angles either. Verts, vertical angles. Think of it this way, and you don't have to draw a diagram. Think of it this way. Pretend two lines intersect each other. How many angles are formed? How many angles are formed? 4. The ones opposite are vertical. Okay? 4 angles are formed when you draw two intersecting lines. The ones across from each other, opposite, are vertical. Okay? Those are vertical. So, here we go. A. Would 1 and 2 be vertical? Are 1 and 2 vertical? No, they're not. Good. I got a follow-up, though. I got a follow-up. They're not vertical. But they are what? But they are what? They're not vertical, but they are? I need more. Adjacent is correct, but you guys have more now in the bank. They're linear pairs, yes. They're linear pairs, which make them? Yes! Now you're starting to pick it up. All right? Hey, they're linear pairs, therefore they're supplementary. They add to 180. How about B? Those look like vertical angles? Some of you may say yes because, oh, look, they look opposite across. But are those two intersecting lines? Absolutely not. So, nope, they're not vertical either. How about C? Two intersecting lines opposite. Hey, we finally, look at that, George. We finally got some verts here. These are vertical angles. Alrighty, good kids, good. Theorem number 2 today, fact number 2. We know linear pairs are supplementary. What about vertical angles? Relax. Let me do some teaching here. Linear pairs are supplementary. What about vertical angles? Well, let's find out. Ready? Addie, can you give me just a random degree measure? What is it, 130? Fine. All right, everyone pretend that this angle is 130. Based on what you know already today, what's the angle adjacent to it? What's this angle right here have to be? Oh, come on now. 50. They're supplementary, right? They're linear pairs, so that's 50. What about this angle next to the 50? 130, and the angle next to either of the 130s? All right, you tell me now. What do you know about vertical angles? How can I fill this out now? Vertical angles are? Oh, we got a better word than equal. Congruent. There you go, everyone. Vertical angles are congruent. There you go. So if you have a pair of vertical angles, they're equal. Whew. Any issues yet? I know I'm throwing a lot, but hey, you guys know this is how this course works. All right, so I got linear pairs. I got vertical angles. Last one here, perpendicular lines. You've definitely heard of those when you did slope last year. Perpendicular lines, two lines that intersect, but they have to form a what? Right angle. Okay, so two intersecting lines that form a right angle. So let's call this line AB. We'll call this line CD. How do you guys know they form a right angle because I put it there. Never mind. So here are two perpendicular lines. But you guys know, I need you to write this stuff mathematically too. All right, how do I write that those two lines are perpendicular? Everyone knows how to write line AB, right? Go ahead, line AB. Nobody in my second period class knew the symbol for perpendicular. There is a mathematical symbol for perpendicular. Anybody in here know it or want to try it?
Is it like a line and then like a line going up?
An upside down what? There you go. There you go. Upside down T. Yes. I don't know if anybody's ever seen it before. Here's your symbol we're going to use for perpendicular. Upside down T. Yep. All right. And then we finish it off by putting line CD next to it. So AB is perpendicular to line CD. That's how I write that mathematically. All right, we ready to relax? Finally try some problems now. I threw all this vocab at you. Now it's time to step back and use it. Questions before we start? Because some of the stuff we're going to do as a class, some of the stuff I'm going to give you a couple minutes to do on your own. This first part we're going to do together as a class. So I have my diagram here. Looks like I threw a right angle symbol in there too. I need another angle named appropriately that's complementary to BOC. What's complementary mean again? Adds to 90. So I need another angle with BOC when I put it together is a 90-degree angle. Look at it, think about it. I'll call you in a second. What other angle, name it please appropriately, is complementary to BOC? Let's go. 2-0. Addie, think you have one? Complementary to BOC. BOE? Okay, if I go BOE, what type of angle is that? DOB? E? O? B? D. All right, relax. Okay, I take that angle and I take BOC. Does it look like it's going to form a right angle? All right, I don't think that's going to, put those two together, I don't think that's going to form a right angle. All right, is there any other angle next to COBOC that I definitely know is going to form a right angle? Why? Because if that's a right angle, what's got to be next to it? Another right angle? And how do I finish off COB? Angle BO. A. Yep. Or AOB if you guys had it. Please don't put angle O though, for what we discussed earlier. There's too many angle O's. All right, supplementary to BOC now. Now I need an angle that adds to 180 with BOC. BOC and adds to 180. So I hear 180, I'm thinking a straight line, right? So BOC and what other angle make up a straight line up here? Come on, come on. Dig deep. Jackson, when you think you have it. Come on. Ready? Here you go. Let me highlight BOC. What other angle put with it would form a straight line? BOE. Well, that is a straight line, right? Watch. BOE is the straight line. So what angle would I need to add to this green one to get BOE? BO. Right? That's not going to give me a straight line, is it? How do I name that angle? COE. Put them together. You see the straight line? We sure? Everyone else see the straight line? COE. And final one. Adjacent and congruent to AOC. Here's AOC. It's got to be adjacent and congruent to it. To AOC. Name that angle. 20. Addie, back to you. Redemption. So it's got to share a vertex and a side and be the same measure as angle AOC. There you go. Perfect. Why? Both of them are what types of angles? Done. Or COD if you want to name it that way. Other questions? Anything at all? Going. All right, so that's good naming. I think the next, here you go. Skip over 4 and 5. We're going to do those last for class. I want you guys to work on 6 through 11 right now. Okay? Skip over 4 and 5. We'll do those as a class, but I want you guys to do 6 through 11 right now. See what you can do on your own. Give you a few minutes. Let's rifle these off. If anybody has a question at the end where I got them, let me know. Okay, let me know. Number 6, EBF. Cheat sheet. Ooh, look at that. Didn't need it. 2s. Aiden, what do you got?
What was it? Oh, 51 degrees.
51 degrees. Good. Again, guys, if you have a question, save it for the end here. What do I have next? EBA. Next one, number 7. EBA. 19. Who do we got? Zach, go ahead. 90 degrees. That was a tough one, right? EBA. Right next to the other 90. DBE, number 8. DBE, number 8. 16, Carter. 17 degrees. I'm good. Yep. DBC, number 9. DBC. Let's go 15. Molly? 107. Good work. ABF, number 10. 16, which would be Carter. ABF, number 12. Number 10, sorry. 151. 51? 151? I got 10 degrees less than that. 141, yes, everyone? 141. And DBF. Final one, 19. Zach, finish it off. 68 degrees. Anybody want to ask any questions on these, where we got them from? Ask away. Kind of like homework. We're comfortable here? We're sure? Yep. 9, which was DBC. Okay, DBC. All right. Well, this was a 39 degree angle, and these two next to each other added up to 90, right? Because I have that right angle symbol here. So that means that angle here should have been, anybody, quick math here, 41? Nope, 51. So that's got to be 51 degrees because subtract from 90. Good. Same thing on the other side. If that's a right angle, that's a right angle. So if that's already 73 degrees, what do I have left over here? 17 degrees. Good so far. So you asked for DBC. So now I look D to B to C. Now I'm going to add up all 3 of those angles. Okay? All good?
Yeah.
Anybody else? 11. Yep. 11. DBF. DB. Okay, same thing. These two added up to 90 because it formed the right angle. So that's how I knew it was 51. These two on the other side added up to 90. So that's how I knew that was 17. Now I follow my letters. DBF. D to B to F. I see in between it's 17 and 51. So I added those up, and that's where the 68 came from. Anything else? Okay, let's go to these tougher ones now to end class. All right, word problems really mess with people. All right, 2 angles are complementary. Stop right there. What's that telling you? 2 angles are complementary. What's that telling me? I got 2 angles that do what? George?
Add to 90.
Add to 90. Now, I'm not expecting you guys to do this, but this just helps me as a teacher to explain this to you. So I have 2 angles that add to, George? 90. So that's what I'm trying to show you right there. All right? All good? Questions? All right, now I got to figure out what those 2 angles are. All right, I got to label them. I know one, it says the degree measure of the smaller is 50 less than the degree measure of the larger. So we need to start off, right there.
Gotcha.
All right, we need to start off by calling one of these angles X. And we need to make a decision. Is it going to be the smaller or the larger one? And it's not, there's no wrong answer here. All right, but the second angle is going to be based on it. So I'm going to let X equal, do we have a class decision here based on the information? Do we want it to be the larger or the smaller? We already know the measure of the smaller is 50 less than the degree measure of the larger. So should we make X the larger or the smaller? Okay, we'll go larger, that's fine. So X is the larger. So how do I write the smaller then? What's 50 less than the larger? How can I write 50 less than? 50 less than, Callum?
X minus 50.
X minus 50 is going to be the second one. So we had to call 1x and then x minus 50 because it's 50 less than. All right, solve. Let's go. Here we go. 2x minus 50 equals 90. We're fine. Move the 50 over. 2x equals 140. And what's our value of x? 70. Now, what's that 70 mean? And this is why we have you do let statements. What's 70, the smaller or the larger, according to my let statements? Guys, go ahead. Larger. And go back, reread the problem. What was I looking for? B. Find the degree measure of the larger angle. So there we go. Because we called x the larger, we found x. Done. So 70 is my larger angle. Not looking for the other one. You can go back and plug it in. Not looking for it though. All right, next one. Two angles are supplementary. Let's stop. What do you know about them? Equal to? Okay, I'm going to do the same thing. One angle plus a second angle add up to 180. All right, now we're going to have to get used to this year. These two angles are in a ratio of 7 to 2. Here's what that means. Let me show you what that means first before we fill anything in. That means one angle could be 7 degrees and the other angle could be 2 degrees. Does that make sense? Could I have 7 and 2 degrees in this problem? Why not? It's got to add up to 180, right? So 7 degrees and 2 degrees won't work. So let's double them. 14 and 4 are in a ratio of 7 to 2, but would that work? Okay. Let me keep one more time because I know this is getting old. Let me multiply both of them by 3. How about 21 and 12? Is that going to work? Okay. I'm not going to keep standing here and multiply by a random number and hopefully they add to 180. I want to set up an equation to find that random number. So 7 to 2, ready? What do I have to multiply 7 and 2 by? There's your variable, x and x. Anytime I see numbers in a ratio in a word problem, I put x's with them before I put them in the equation. What do I need to multiply 7 by and 2 by to add them up to be 180 instead of guessing and checking? All right, finish it up. 9x equals 180. So x is going to be equal to 20, but is 20 one of the angles? No, hey, 20 is not one of the angles. It's just what I need to multiply by. So let's go back, find the degree measure of each angle. One angle is going to be, what's one of my angles going to be if x is 20? How'd you get 40? 2 times 20 gives me a 40-degree angle. The second angle, now I do 7 times 20, and that gives me 140. All right, so x just tells you what you need to multiply each of the numbers by. And quick check, are they supplementary now? Yeah, that would have taken us a while, huh? Guess and check up to 20, since I started with 1, 2, and 3. So anytime you have numbers in a ratio, please put x's with them before you put them in an equation. And then you guys have the last problem to do today. That's your last problem here for today. Thank you, Eric. Have a good day. Thanks for coming in. Read the directions. Everyone see ABD and DBE are congruent. Put your markings on your diagram. Go ahead. Put your markings on. ABD congruent to DBE. ABD congruent to DBE. They have the same measure, and ABC is a straight line. Angle EBC is 40. All right, see what you can do. Try to find those other two angles based on what we've talked about today. Good job, guys. Good job. What do you know about the straight line? Equal to 180, right? You already have 40 degrees. How many degrees are left for the other two? 140, right? And what do you know about those two angles? And they add to 140. How much is each angle? 70 degrees each. All right. Thanks for sticking with it. Hey, last thing, got to have compass and straight edge tomorrow. That's all we're doing tomorrow, our constructions. All right, that's all we're doing. So please have it with you. Good work today, guys. Good work.